Okay, so this is a video for 6.1.3 on apex, exponent properties, and root properties, and they go together. So let's start with when you have some bases. So this is the base, and these are called the exponents or the powers. So when you have two bases that are multiplied and they're the same, you get to, instead of multiply, you add the exponents. So since I see multiplication, you do 2 plus 4, which is 6. So 4 to the 6th. This one over here is 4 plus 4 is 8, so 3 to the 8th. Remember, that only works if your bases are the same. On this one, you have a base that has a power to a power, so it has an exponent with an exponent on it. I like to connect them. When you connect them, you see that it makes an x, which is multiplication. So you multiply the 2 and the 3. So you get negative 3. 2 times 3 is 6 to the 6th. Here, 3 times 3 is 9, so 4 to the 9th. When you see two bases, so here's a base, with two exponents. This one has an exponent of a 1. I like to draw the 1 in. See this division sign? See how it kind of looks like subtraction also? You're going to subtract. 4 minus 1 is 3. 3 cubed. This one's a little bit different. I do this two different ways. 2 minus 3 is negative 1, but you don't want to have a negative 1, so what you're going to do is put it on the bottom and make it a positive 1, and then the 1 would be a placeholder. The other thing that you can do, which I like, so 2 squared really means that you have 2 2's, 2 times 2. 2 cubed means you have 3 2's, 2 times 2 times 2. Cross 1 out from the top and the bottom. You're left with 1 left on the bottom. You do need a placeholder on top, 1/2, same answer. Okay, so there's a few different things that they want from you in the quiz. At first, they just want to show that you know the properties, and then they actually have you do them. So for here, we're not actually going to multiply, but if you did have root 5 times root 20, you could do root 5 times 20. For some of the problems, I think that's as far as they want. Now, they will never give you two correct answers. So either it'll say this, or it'll say, okay, well, 5 times 20 is 100, so root 100. Eventually, they will want you to know the perfect one, so square root of 100 actually is 10. But so any of those three would be correct answers. It just depends on which problem they're asking you for. So this one would be root 3 times 6 or root 18. This one's not perfect, so we're not going to break it down. Root 5 times root 5 is root 5 times 5. 5 times 5 is 25. This one actually is perfect. The square root of 25 is 5. Okay, let's move on to this one. So this one, they could ask you a couple of different ways to do it. So you have root 15 over root 12. That's root 15 over 12. They could ask you to reduce the numbers. 15 divided by 12. They are both divisible by 3. You can separate them again. Oops, root 4. The square root of 4 is 2. We're going to do some practice problems from the checkup, so we'll see actually how far they want you to go with those. But there are some that are perfect, so like the square root of 4 is 2. The square root of 9 is 3. And the square root of 5 divided by 125 reduces to 1 over 25. The square root of 1 is 1, and the square root of 25 is 5. Again, we'll do some more actual problems from the check-in. So here's some actual problems. So why don't you pause the video and try these first two, and then play the video and see what you get. So for this one, you see the multiplication of two bases, so you add the exponents. 3 plus 4 is 7. This one has a negative exponent. Negative exponents bring the base to the bottom and become a positive exponent, and you keep a 1 as a placeholder. Okay, go ahead and try these two on your own. Pause it and then come back. Okay, for these two, you see multiplication. 3 times 5 is 15, 4 to the 15th. This one actually distributes 5 to the 9th times 4 to the 9th. Okay, try these two if you want, and then you can pause it and come back. This one distributes also 2 to the 6th over 7 to the 6th. Okay, so this one we have not talked about yet, but I was waiting until we got to these problems. If you have an exponent that is a fraction, what that means is that it actually is a root as well. The bottom number of the fraction goes into the index, and the top number goes as an exponent. So x to the 1/2 is the square root of x. Now, if you don't see a number in the square root, it's a 2. For your own work, you could write it, but we don't write that as mathematicians. So you just won't write it. And then again, the 1 you don't write either. So this means square root of 81, because the 2 is here, the 1 is here. This one's actually perfect. The square root of 81 is 9. Some more problems here. So the square root of 64 times 121, you can break those up. Square root of 64 is 8. Square root of 121 is 11. 8 times 11 is 88. Rewrite this with exponents. So like we said before, when we had x to the 1/2, made the square root of x, and the 2 went here. Well, if it's here, that came from the bottom, so the bottom must have been a 3. There's no exponent here, so it must have been a 1. Try another one. Like, what is the 4th root of 5 to the 7th? Well, the 5 is the base, the 4 is the bottom, the 7 is the exponent. 9 fourths to the 1/2. Remember, you can distribute that to each one. So the 9 has a 1/2 and the 4 has a 1/2. Each of those 1/2s are square roots. Square root of 9 over square root of 4. Square root of 9 is 3. Square root of 4 is 2. 3 over 2. Exponent properties. You multiply these. 3 times the 3rd is 1. So this is 4 to the 1st power, which is 4. Okay, hopefully that helps. If you need anything else, let me know.